Okay, I can see people are joining in. Let them, and we can start. Cool. So, thank you, Anurag. See you. All right. Very good morning to all of you. And thank you for joining on a Saturday morning, which is a huge task. I know that. Uh, how many of you are excited for the day? All right. So I'm going to put off the slides for a minute. Shiny was saying something?
No, I thought I was on mute. Sorry.
So for the rest of the workshop, I'm going to ask you all to put your video on. If you're in front of your laptop and you're comfortable, do put your videos on. And this is going to be an interactive session, which is why we have such a small crowd. It's not 100 people, it's just 11 people. So we're going to be talking a lot and we're going to be sharing our code back and forth, which is why we have the WhatsApp group also. So that's a small request. So if you all can put your videos on, and we'll start with the introductions. I'll start with me. I'm Bhavani, and I'm a freelance software engineer. I've been fiddling and playing with Python for the last 10 years. And to really reel in on my Python skills, I've presented at PyCon Australia and PyCon India twice. So I'm here to share why I love Python so much and why JavaScript has never replaced that spot for me. So I want you all to experience what I experience with Python. So with that, I will pass the mic over to you so that you can introduce yourself and let's get started.
Okay, I'll go next. I'm Shiny. I have some experience with Python and I've also worked with JavaScript. So yeah, I've never got into the depths of Python. So that's why this workshop excites me.
Yes. Shiny is always humble. She is also an amazing Python developer. I know her, I've worked with her. So it's just that she's humble. So
Thanks for
who's next?
Okay, I'll go next. I'm Vinita, currently working as a QA, new to Python. Just wanted to explore Python and start my career as dev with Python. So I am eager for this workshop.
Wonderful. Another humble person, Vinita, is a self-learned Python developer. She has gone from manual QA to an automation QA. How I know that? Because I worked with her, another amazing person. So thank you for joining, Vinita.
Yeah.
Who's next? Pechi?
Hello. Yeah, hi everyone. Myself, Pech Nikul, and I'm a Python developer. I'm working, overall, I have 9 years of experience. I just joined this meeting, to learn more and in depth of the deep dive in Python. I already joined MCP last time.
Okay.
So, that was very good, so I want to know more about this.
Okay, wonderful. Given the experience, I hope I can also learn something from you. Because 9 years, I don't know. You should have touched more Python than me. So let's see. We can learn from each other.
Yeah, sure.
Who's next?
Yeah, I would like to go next.
Vignesh.
Yeah. Hi, hello everyone. Good morning. I'm Vignesh. I am a Monstack developer at Cognizant. So, Python is pretty new to me, but have a little bit of understanding on the basics of Python. And I want to explore more on Python. So I think this would be a good, stepping stage for me. So that's it from my side. Thank you.
Definitely, Vignesh. I hope it will be like that. Who's next?
Hi, this is Vivek.
Great.
I'm from Bangalore and I know basics of Python. I'm into QA, so I want to explore more in Python for automation.
What do you do, Vivek?
I'm QA in telecom.
All right. We have evidence of QAs just doing better than classic Python developers, so I have a lot of hope for you. So I hope you find value in this. Next, let's do Kabil.
Hi, can you hear me?
Yes.
Hi, I'm working as a senior data scientist in one of the fintechs. I'm using Python for the last 6 years,
Okay.
but still I wanted to learn more advanced in terms of class and modelization, so I just joined for learning.
Can we also have our videos on at least for the introduction so that we get to see each other? That's more cohesive because it's an online event. Who's next? Karthik, Aditya. Lakshmi, would you like to do your introductions?
Hello.
Yes, Karthik.
Hi, Bhavani. Hi, everyone. My name is Karthik. I'm from Hyderabad. I'm working in a startup for the last 3 years. And my Python expertise is somewhat flaky because I've just replaced 1,000 places dictionary off to dictionary.get. So yeah, I want to learn more on what makes it like great, not just good. So yeah.
Yeah, we'll definitely see the amazing parts of Python. I hope you find value in this. Next is Ram. Hi, Ram.
Hi, Praveen. So basically, I'm from a Ruby background. So I started my career in Ruby, and I was working in Rails framework for 8 years, and then so not just the Ruby, and I was working in JavaScript, a little bit of PHP here and there, and building websites and all those things. So currently, I'm working in front end. So I have a 10 plus years of experience overall, but currently I'm working in Next.js for a couple of years. So recently I started looking into Python from like a couple of weeks before. So this started with the basics. So now I'm like stuck between front end and back end. Like so I was a full stack. But right now I'm working in just the front end. I'm just wanted to learn like Python and all. I don't know whether I would be able to like set my career in Python. I'm not sure still. Just I wanted to explore more on this. So I think this session will be more helpful.
Definitely. Given that you already know Ruby so well, it should be easy to adapt these
Yeah,
patterns back there. I hope you can, relate back to Ruby and say, hey, Ruby does this better, and
yeah.
you get that. Yeah. Thanks for
Thank
that, Ram. And who's next? Lakshmi?
Uh,
Yes.
Hey, my name is Aparna. Sorry, my camera is not set up, so it's it's a little bit weird. Like, sorry, but yeah. So I've been using Python for 2 years, but mostly pandas. So I want to like expand a little bit more, and write more Pythonic code in general. So that's why, yeah.
Wonderful. That's a great place to be in. Definitely going to be valuable. Who's next? Come on, guys. We want to get to the depths of Python. So, who's next? Arun? Michael?
Yes, Pavani. Good morning.
Would you like to do your introductions?
Yeah, I'm Michael here. I have been working as a data engineer in investment banking domain. Actually, I wanted to learn about Python memory management and generator and iterator
Okay,
to create a better pipeline. That's what I enjoy here.
nice. Cool. So I will stop the introductions here. If any of you want to introduce yourselves, just unmute and go for it. But for the sake of preserving everybody's time, we will go on to depths of Python, which is what we are going to do for the rest of the session. And you all introduced yourself, and you all come from different backgrounds. And This is something that brings you all together, the need to learn more and more Python. And you have mentioned this. You want to deep dive into Python, you want to learn more about classes, meta classes. I don't know what I want to learn, but I know I want to get better. And Vignesh, the session is already being recorded. I will share the recording after the event. You don't have to record it on your own.
Yeah. Oh, okay, sure.
So, and then you're a beginner, so all of that. So this is what brings you all together. Note that you all need to know more Python. And one thing that I want all of you to be comfortable in this workshop is to say, I don't know. I don't know how it works. I don't know whether it's working. I don't know what I did wrong. All of these are perfectly reasonable things to feel, and it's okay. See how that it's okay is huge and I don't know is very small, and that it's okay is important. Okay. So make mistakes, learn. You're here because you don't know. So it's completely fine. With that, I don't have more slides. And for the rest of the session, I don't have more slides. It's all going to be interactive talking, right? And unlike other workshops, I haven't given you a lot of instruction as to do this, install that. And that's because I want all of you to start with a fresh slate. So I don't know what code editor you guys use. What code editor do you guys use? I use VS Code.
I also use VS Code.
Yeah, same.
Yeah, VS Code.
Almost all of you use VS Code. And since you're all developers, I hope you know your way around VS Code. So let me close all this, clean this up a little bit. So this is how my VS Code looks most of the times. I have my project here, I have a bunch of files here, and I have my I work always on the VS Code terminal. And in your system, when you do this, I want you to type Python and you get some version of Python, which is 3.10, 3.11, 3.12. It doesn't really matter for this one. So tell me that you all have Python installed and what version you're on.
3.12.0.
3.12.0 is perfectly fine. 1.3, 1.3 is good. So this is your,
3.8.
sorry?
3.8.
8 is also fine for this session. We don't really go anything more than that. If at all it becomes a problem, we'll see. 3.8 should be good for most of the session. So this is your Python shell. You can type your Python commands here, all kinds of commands, for loops, everything. And you can exit this with Control D, or you can do exit off to exit the shell. So most of the beginners struggle with the differentiation of your CLI commands, which is ls, if it's Windows, it's dir, or any kind of CLI command, cd. This is your bash commands. This is bash scripting. This is your Python commands, which you have to type in the Python shell, right? Some of you are already developers, so this might be easy to you, but as a workshop, you have to cater to beginners also. So there are two distinct things. Whatever you type here is your bash commands, which is a different programming or different scripting language altogether. And whatever you type inside Python is Python code. So all your print statements and all your for loops for I in range of 10, print of I, all of this comes in here. Now, I've seen people copy Python code and just paste here, and that will not work because it considers that to be a bash script. So please don't do that. The next thing that we want to do is this concept called virtual environments, which kind of throws everybody at the moment you leave the beginner system. Then you kind of get thrown off by this virtual environment concept. So that's what we're going to touch in a little bit. If you don't have VS Code installed in your system, open any terminal of your choice. For example, let's say I open this terminal here, and I can work out of this for all my Python shells like that. Okay, Python 3 probably, because this is not set up properly. Cool. So that's Python 3. and use any code editor of your choice. It's Cursor, VS Code, Sublime Text. I don't know what other things are there. If you have any other idle of your choice, you can use that. So that is all that you need. Before we go to virtual environment, you have two of these. You should be able to open this and read this. If it's in like a JSON file, you can also, you don't have to install anything for this. Okay. Python. If you go to the GitHub repository, I'll also paste the link again in the chat. If you go to the GitHub repository and open this steps of Python, it will automatically give you a very nice UI of all the things. So you can also copy paste. This is just for your reference. We won't be running this live. You can run this and see. So next, we will talk about this virtual environment concept for a little bit, right? Now you have seen that we use Python. I use Python 3.12 here and Python 3.13 in another shell. Now this is going to be very common in all the projects that you use. Okay, so I'm gonna pin up. Just give me a second. Share. Stop sharing here. Pull up a whiteboard. Cool. So tell me, what do we use virtual environment for and what it does? Let's make this interactive.
For isolating the project, package dependencies.
Yes, absolutely. That's exactly right. So let's say I have a project 1, and I have another project 2, and then Shiny drops another project to me like, hey, Bhavani, can you check this project? And that's another project number 3. And similarly, everybody here comes up with 15 different projects. And each project has different Python installations in it. Let's say this is on 3.11, and this has to have 3.12, and this has to have 3.13. And this segregation doesn't, like, in your system, you cannot have multiple Python installed at once, right? So that is a different problem. You can't have multiple instances of Python alone installed in your system. You can in Mac. I'm not sure about other systems. So like I said, like I did, if you type Python, it was erroring out. And when I did Python 3, it was working fine. But when I do Python 3.12, Python 3.13, it might have a conflict, right? That is a different problem. We will come to that. But let's say I have another project called project 1.1. Now let's isolate the problem. We are not caring about, we assume we only need one version of Python. We don't need other ones. So in these two projects, I'm still using Python 3.11, but this one uses pandas. Let's say I'm randomly picking some version. It's not a real version. So I'm using pandas 1.10, let's say. And this one, oops. Yep, this is a problem. I haven't used this before, so I don't know where the undo is. It's okay. So another one uses pandas, let's say 1.13, and these two are completely different. Even one step ahead, let's say it uses pandas 2, and these two have completely different syntax. This is when you need a conceptual segregation between the packages. Like the packages used by this project is different from this project, and that's when you use the virtual environment. We are still not talking about these two, and that's a different like Python environment thing. This is just virtual environment. This is a virtual space where you can install different libraries in different spaces. So what it does, it takes the Python version, like the underlying Python version, and every time you create a virtual environment, you have the Python version underlying 3.11, and it creates a space for you to create the site packages. This is a folder that you can find inside the virtual environment. This is one of the folders, and then you will find a Python installation inside this, like not an actual Python installation, but a reference to it, right? And it will have bin, lib, all of that. It's like a virtual thing, right? So it creates that and assigns it to you can assign it to a specific project. Similarly, you can have one more virtual environment, which is also a copy of this Python, and it has its own conceptual space to install the libraries, right? So I'm going to pause here for questions. And then let's see. Any questions here? Where does Docker come into the picture? Docker is so far into the system, like if you have, so you want to run something on your system and you want to run something, the same thing on a different system, you package it. So in Docker, rather than copying the Python's underlying layer, you will be copying the OS layer, right? It's the segregation at the OS layer, whereas in virtual environment, it's just pertaining to Python. In JavaScript, you have something called as node modules. Usually node modules are associated to a particular project. Python is also going in that direction, but since virtual environment was an independent concept. For example, suddenly you decide you're going to migrate this Python pandas 1.10 to 2, and there is no difference between these two now. You can also attach this project to this virtual environment without doing much change. So that's the difference. In Python, it's not tightly coupled. So any virtual environment can be used with any project. But in recent times with UV, poetry, and stuff like that, it's changing. So that's a very small but a huge concept. You will be using this now and then, every now and then with every project. So that's that. The screen keeps blanking out with whiteboard. If it's still happening, let me know. There is some issues with this. Probably I'll change to a different one. Cool. So that's virtual environment. Any questions on virtual environment? Let's tackle it now, and we will be creating a virtual environment in a bit. Cool. Now, there are also ways to do this. Having different Python projects for different Python versions for different projects. Now these, you have variety of packages, PyEnv, PyVM, stuff like that. Every possible combination, there is one package. I don't have a recommendation. You can pick one and use it. So these have its own commands. This is not coming out of the box in Python. These are external libraries that creates proper segregations inside your system library, like inside your users or system/user or user/system. Inside here, it will create proper folders for each Python version. And then you won't directly use that Python version. You will always do something like PyEnv Python so that it knows which version you're using, or PyEnv use 3.10. Then it will know which Python version you're referring to. And that's just a library configuration. This library is enabling you to do it, not Python itself, which is why I'm not giving this a lot of weight. So it's similar to, yes, it's very similar to NVM. But again, like NVM is now becoming a part of an ecosystem, but things like this are still like kept at a distance in Python ecosystem, which is why it's not very prominent, but it's very still used, right? So we are not going to worry about what Python version we have right now, but we are going to at least create a virtual environment. The easiest way to create a virtual environment in Python is to use Python itself. As I told you, Python still works. So Python -m. -m means module. And don't get worried about all of this. I have some crazy setup so that all of this comes up. So Python -m means I'm referring to a Python module, and venv is the Python module. I can create my virtual environment. This is my virtual environment module. And then I have to give the name of the module. This name of the module can be anything. Let's say depths of Python. Make
Pitch the screen.
yeah. Oh, I'm so sorry. I have to, oops, I have to stop share here. That's a lot of screens, so you have to clean up in a bit. Cool. So Python -m means module, and then VENV means virtual environment. This is a virtual environment module inside Python. What do I mean by that? If I go back to typing Python and I import VENV, it's a module. I can do VENV dot and I can find out what are all there inside a VENV module, right? It's not much, we won't use much, but this is what is inside a VENV module. So Python -m VENV, and then you can name your virtual environment anything, DOP 2025, let's say. Now we have Python. Happens. So Python -m VENV. See, it has created DOP 2025. Inside this, you have bin, which is like a copy, almost like a copy of all things Python, all the Python shell commands and pip commands. And then you have activate script to activate the virtual environment. And you have lib. Inside lib, you will have site packages. I cannot see site. Oh, we are inside site packages. Yeah. You have site packages where all your libraries will be installed. Now to activate it in Mac, I use this .venv or the virtual environment I created, DOP/DOP 2025, bin/activate. You don't have to do all of this. You can just use your system Python. I'm just showing you to get an understanding. Okay. So this is what I do in my Mac, and then I get this because of my shell setup, I get this DOP 2025. I also have another virtual environment which is called VENV. Inside this, I have a bunch of things installed, which is why you see all of this. So similarly, if I go and install some package, let's say pip install, this is something I tried yesterday, so let's install that. OBJ graph. You can also see that OBJ graph being added here. So now you're not going and writing in the system space. Rather, you're writing it in inside your project, and you can export this. How do you export this? So if you do pip freeze, as long as you're doing pip install, it will give you a list of all the libraries that's being installed in this virtual environment, not on your system. For example, if I deactivate and then do a pip freeze, I'll get a lot of crap. This is all the things that's installed in my system. Whereas the moment I do activate and then do a pip freeze, I only get the things that's installed in my current virtual environment. If you have been using Python and you know virtual environment, this might be a little bit boring, but this is essential. Every time you start a project, you also start a virtual environment. So any questions on virtual environment? Yes, UV is new Python package manager that has been really popular. Like you can see, I've also included UV here. So for UV, the reason for not touching it right now is you need to know the commands and it might get a little complicated, right? So let's also go explore UV in a different way. Let me close this and UV Python. So to install Python latest version, like I said, PyEnv, all of that was there. Now UV also allows you to install specific versions of Python and then work with it. Like here you can see you can install different versions of Python. To install UV itself, you need to go through this for Mac OS and this for Windows. And UV also has special ways to initialize project. Let's say I haven't used this much, so scripts. Never mind. Let's do this. I'll create a new directory. UV tutorial, let's say, and then cd into UV tutorial, and then I'll do UV init. This will initialize a project called UV tutorial, right? It gives me a main.py file and then gives me a pyproject.toml. And then from here, what I'll do is UV add, let's say OBJ graph was something we were using, right? This is some random library. The moment I do that, it adds that to the dependency. And now it doesn't actually create a virtual environment out of the box. But what you have to do is every time you want to run something in that virtual environment, you want to run something with this dependency, you have to run it with UV run Python. So UV run Python is a separate installation of Python. It's not your system Python. So it creates all that virtual environment behind the scenes. And then you have to start using the main.py, which is why I haven't introduced you to UV. So all the nitty-gritty things that we saw out in the open, like this one, it does it behind the scenes. So it has its own installation of Python. It has its own installation of OBJ graph. It's maintained somewhere. And when I do UV shell, this is not right. There is also a command to initialize or like use the virtual environment created by UV. I'm not sure of it out of the box, but it is there somewhere. So let's go back to depths of Python. Unless you have more questions on virtual environment itself, let's move to a different one. I'm going to delete these things. So what should you have right now is when you type Python, you should have this, and you should be able to do pip, and you should have a lot of things here. If you have that, you are good to go. You don't need to worry about virtual environment because we are not going to install a lot of libraries at all. We're going to use all things code Python. Okay, let's go through the chat. What is UV? It's like NPM. Yes, it's like NPM. The closest thing to NPM is your pip, which just comes out of the box with Python. But UV is an advanced version of NPM with a lot more bells and whistles and makes the life definitely easier. Conda versus UV versus poetry. Conda initially came when life of data engineers or data scientists were difficult because scientific Python needed different installation mechanism. But I have never used Conda in the last 10 years. I have always found it very difficult to navigate around it. Poetry came way later than Conda, and it definitely had a lot more bells and whistles than Conda or pip or virtual environment, and it wanted a standard way of Python installation. So Poetry came and it gave a very nice interface. UV is exactly Poetry but written in Rust, which makes it a lot more faster. That's the only difference between Poetry and UV. You can use both. I go with UV because it's a lot more faster. Right? Cool. So we still haven't scratched the surface of Python. We just did, okay, create a virtual environment. If you want to create a virtual environment, you can go through this route of Python-m. This is a constant command. You can create a shortcut for this and keep it. Python-m vnvtop, and then you activate it, right? So I'm going to delete this. Cool. Are you all with me? Can we move on to the next thing? Give a thumbs up.
Yes.
Yes, okay, cool. So the next 30 minutes is going to be a little theoretical, like the virtual environment, but this is essential for us to design further systems, which is a memory management of how Python internally stores variables and everything. So for this, if you want to follow along the way I do, I actually recommend this. Install pip install notebook. If you do this, no need of any virtual environment, nothing, just to pip install notebook, and it should install Jupyter Notebook for you. Yeah, not on my virtual environment. That's why. So it should install Jupyter Notebook for you. That's still scary. I don't know why. It installs a lot of things, and then we do Jupyter Notebook, and you should have Jupyter Notebook opened on that particular space. So let me know if you have installed Notebook and then you start Notebook with Jupyter Notebook. Not exist.
Bhavani, we can also run notebook on VS Code, right?
Yes, you can.
Okay.
I find it really slow for some reason, which is why I don't run it. Tried it yesterday, didn't work.
Okay.
So if you all have the notebook open, let me know so that we can start. Okay, this has screens. We also need sharing permissions for both. Are you all good? Can we move on? The commands are on the chat. Pip install notebook. Jupyter Notebook is open for me. Good.
Oh, wait. So we don't need to install the Jupyter Notebook globally, is it?
We can. You have,
Okay.
it's not a problem. I have my setup I always have my setup inside a virtual environment, so that's something. If you have it globally, that's fine too. And it's easier. Let's see if this works this time because I have also shared another screen. I hope. Okay, that's about right. All right. So we are going to start with memory management. I hope you all have this running. So when I talk about it, you can also try running it, right? So when I do in Python, I have two variables here, x equal to 256, y equal to 256. And I find ID of these two. And I compare these two's ID. And it says the ID is true. And when I do 257, just one number above that, it says that ID is false. Why is that happening?
Bhavani, sorry, we are seeing the white screen.
Oh, you should be able to see it.
There are two options. You have to change the view options to this screen. Actually, there are two screens.
Okay. Okay. Thanks.
Cool. So then I'll stop this for a minute. We'll come to that separately. Okay, cool. So you have x equal to 256, and no matter how many times I run, the x and y's memory, again, ID of x means the memory address of x. That's what it means. And when I compare the IDs of these two, the memory address is same. And when I increase it to just one number, it becomes false. It's not the same memory address. You can also try printing it separately. ID of X, comma, ID of Y. It won't be the same. Why do you guys think this happens? This is the part where you put on your videos and say, unmute yourself and chat. And the whole workshop is going to be like this.
I think the number 256 and 257 are stored in different locations.
Same number, same memory address, but 256 and 256. Here it is same. Here it is.
So, I mean, since X and Y are two different variables, right? So, I think it would create two different addresses. That's what I feel.
X and Y address.
Even though the values are same, but the address will change because both are different variables. I'm not able to hear you.
Sorry, can you mute yourself? So
Now it's audible.
yeah, now here it's two different variables, same number. Here also it's two different variables, same number, but it has two different memory addresses. Here the memory addresses are same. Here the memory addresses are different. And I can also change this number, right? I can do 10. And it will still be the same. And I can change this number to, let's say, 10,000. Will not be the same. So there is something happening. Let's keep exploring until we kind of find an answer. Let's keep reducing this number maybe to 1. Two different variables, same memory address. Let's try negative numbers, right?
Is it something to do with like it is interpreted and not compiled?
No, it's not.
Already in the first column, like its memory, something is 27, which within that two values are there. Here it's in different line. I am not sure I'm correct or not, but somehow I think. Yeah, this one.
We do it this way, it will have the same address. Let's try it. Yeah, that's a good theory. Doesn't look the same, it's different, right? So let's keep going to a point where
Maybe like first time when we are setting, right, that time it is taking the same address, but after that when you're changing the values or assigning the same values for the same variable, then it is, differing. I think that's it. I mean, I don't know if I'm correct.
I love these theories. Please keep them coming, even though it's wrong, because these are what designers do, right? Oh, maybe we can design it that way. And that's completely possible. Whether it's right or wrong, that's a different ballgame altogether. Maybe because it's in two different cells, it has different memory addresses. That's a design pattern. So that's a design decision that you take. It's not the one that Python implemented, but that's completely possible. That's what I'm trying to say.
I have a question here.
Yeah.
In the first, like on the this 33 execution box, you are doing the like you are initializing it, right?
Yeah.
Defining it for the first time. But on this 31 block, you are doing it second time, which is like reassignment.
Yes.
I think maybe it's like it has something to do with that.
Okay. That's also a very good theory. But let's say I will do something else then. We'll test all these theories, right? Let's have this. And then let's do A and B. Okay. I know some of you have problem with the notebook itself. We'll come to that. I know I have to tell you the commands to run and stuff. So the first theory was, remind me again. I'm kind of Okay, we were at making it minus 14. I think I reopened it. Now, when I made it minus 14, you can see that it's different. Suddenly it became false. It's no longer in the same memory address. So it's not something to do with the order in it's occurring and stuff like that. This we increased as big as 10,000, but it is no longer not going back to the same memory address. So if I do this, it's not the same memory address. If I do this, it's still not the same memory address. So it's not what this is doing, right? So let's keep pondering over that question, and I will give you the answer, of course. That's what you're here for. There is one more concept, right? Let's actually add more cells. Now, what I'm going to do is I'm going to create a list, and currently these are in different memory addresses, and I'm going to create a list called 1. Before that, let's take this A and B and make it, let's say, 10. And I'm going to create a list which has 10, A and B. Now, for I in L, print ID of L. Now you can see all of these has same memory addresses, right? Now let's say I increase it all the way to the top. And now I do this. All of this still have same memory addresses. Oops, sorry. It should be 10. Yeah. These all have the same memory addresses. I think I haven't ran it the second time. Yeah, it still has the same memory address. Why is that happening? Now it's 10,000, 10,000, 10,000. It's all having the same memory address.
So what about ID of I instead of L?
Oh, sorry. Sorry. It should be ID of I. Yeah. Oops. Yeah, then I kind of like got lost there. So when I do 10,000 plus, it's all different memory addresses. But if I reduce it to a value, let's say 10, kind of, it's all the same.
Maybe smaller number getting stored in one
Yeah, it
variable.
is it related to digits specifically? Some particular digits, like 5-digit number or 6-digit number, means the address will vary. If it is below 5-digit number, like 10, 100, or 1,000, that comes under one set of address or something.
Wonderful. I think you guys are close, very close. So
But it is related to ASCII values. So.
no, not ASCII values, but that's also a good theory. Maybe an ASCII values, maybe number of digits. So to test this, we have kind of found out within a range, it's the ID is same. Within outside a particular number, it's not the same. So to really reel in on this idea, let's create a range that goes from -10 to we saw 257. Let's go up to 300, right? So I'm starting from -10 because we saw -14, it's differing, right? So -10 to all the way to 300. And then let's print the ID of I. It's going to be a long list, so bear with me. As you can see, this is a lot of numbers. This is let's also print I and then that. So -10, different number, 560, 592, different number. But how do we know two of them are same? We need to also somehow do something else. So let's create an temporary variable here and assign it to I, such that assign it to that number I, such that we can compare these two ID of I and ID of temp. This is the closest I can think of. Okay, something happened and I'm lost of space. But still, this is not right because we are assigning the same variable. We need something else.
I plus 300 or something. Idea.
No. It's okay. We have these IDs. It's okay. Let's refer that. So minus 10 is here. Let's do a little hand holding to this. Let's create a temporary variable and assign it to minus 10 and then do ID of temp. Now with this, we can test it. So here you can see minus 10, two different values. It's 264912. Let's come all the way down to 0. And then let's see. It's the same, 136. So let's go a little bit to the top and do minus 5. And this is the same number as here. If I do minus 6, it's a different number. 264 and 926. So I'm kind of doing a binary search. So 10 was a different number, 1 was the same number, and somewhere in here, minus 5, it's the same number. 976. This number is same as this number. So let's also test it again. Let's see, temp1 equal to minus 5. And then ID of temp1 equal to. So both are kind of same. We should do equal to and here. Cool. It's the same number. So again, we know 256 is the last number where this 2 matches, and after which it's gone. So if I make this again 257, it's going to be gone. So it's from minus 5 to 256. Now I could have just said 256 to 250, minus 5 to 256, it works, but that's not the way to learn. This is the trial and error method of finding out where the answer is. So now we'll go under the hood and see what's happening. I'm going to stop this screen and bring up this one. Once again, share screen, stop podcast. I hope this screen shows up without any glitches. Now, we're going to cover a lot of concepts. This is just memory management, right? Let's say you have a memory like this. In Python, we like to do things fast, even though it's a slow language. That's what people say. We like to do things fast. And one of the design decisions that the developers of Python take, Python is a programming language and it's written in C. And it's also written in other programming languages as well, but it's written mostly in C. So the developers of Python programming language itself decided we want to make things fast. And one of the ways to make things fast is by keeping things ready when you need it. And this ready is mostly integers that occupy memory space. So every time you load an integer, which is very frequent, and every time you load an integer, if you create a memory, allocate some space, and put a variable in it, it's going to be time consuming. So what they did, until minus 5 all the way to 256, you will always have it in memory. Okay, so what? You have it in memory. These numbers are loaded in memory. How does that make anything efficient? I will do x equal to 256 and I have to create a memory, assign 256 in it, right? That's going to be time consuming. No, we are not going to do that. Instead, what we will do is, this is not what's happening in Python. Instead, what's really happening is, in your memory space, we create a variable called x. And then on the value, you don't store the value directly, but you store the memory address of that particular variable, right? So let's say this memory address is 1001. This is also 1001. So when you ask for x's value, it doesn't directly get the value. It gets the memory address. And then from the memory address, it goes to the value, gets the value, comes back. So until minus 5 to 256, since it's already in memory, you can create another variable called y. And it will say, oh, what's y value? Again, 256. I already have it in memory. So I already have it in memory. Let me go refer that again. And this is only for these variables. The moment you make, let's say, a equal to 257, the other variables, it no longer does this optimization. If you make a equal to, if you make a equal to 257, it creates creates a space for 257, let's say 1002, and then creates 1002. But again, when you create b equal to 257, this optimization until 256 doesn't happen anymore. It creates a new memory address, let's say 1007, 257, and then, but the maintenance of memory address does not change anymore. This is how variables are created and maintained inside Python, right? But this is a memory optimization, happens only for -5 to 256. After that, it doesn't happen, but the maintenance of memory address remains the same. Now, in case of lists, now let's say I create a list with 10, A, and B. Now let's create a memory for this list. I hope you all know what Python lists are, right? List. And then you have 3 items in it. So 0, 1, 2. Now I have to store 0th item, 1th item, 0th, 10th, like the 3rd item. How do I store this? What memory address should I persist? What memory address should I persist for 10? Even make this -5 and then make this, let's say, 1002. For some reason, 2 memory addresses, 1002, 121. Okay. So 10, I already have it in memory and it's within my range. So this will be 1021. And 1 is A. A's memory address is 1002. Technically, this has its own memory address. This has its own memory address. So I will make a reference to this 1002. And then B has its own memory address 1007. So when you do L of, let's say, L of 1, then it goes to this memory address. It says 1002, goes all the way to 1002, picks that value out, comes. I'm going to pause. The first one should be 1021. I'm just giving random numbers, it doesn't really matter.
But based on the previous example that you showed, right? All the 3 had the same addresses.
Which
No, when you showed in the Jupyter notebook, right, for an array.
No, if it's the same value.
Oh, okay.
If A and B is also -5, then it will have the same memory address. Now, in this case, it's 257.
Okay, understood.
Pavani, actually, L is a totally different data structure. Yeah.
Yeah.
How it will be refer the individual memory address?
So because you have mentioned A, technically it's A's memory address, not really 1002 directly. It's A's memory address stored in this. So to see that in Python, I'll show it in the Jupyter notebook also. It's since you have created a variable A and A has a memory address, that memory address is what gets stored internally for that variable.
So the memory address of this list, if you take ID of L, will it be different?
Yes, ID of L is different. ID of L is somewhere, let's say ID of L is here, right? It can be in a different, this L has its own memory space. Now, that's a good segue for a different concept. Now, let's say I create a dictionary. I can totally confuse you out. Please stop me and ask questions, okay? So I'm creating a dictionary 1, and let's say I'm creating the value to be L. I create a dictionary whose key is 1, just 1, and the value is this L, and this L is somewhere in 10024. Now, in memory of this dictionary, you have 1 and 10024. So it's all intertwined. And this graph resolution that happens internally is what you call as AST trees or graphs, right? So this is a very interesting problem. You would have learned graphs and graph resolution, the closest path and stuff like that. This is where it's actually used in program design, right? This is so, the first time I saw this was in a PyCon conference, India, and I was just mind blown. Wow, you just do x equal to y and go, but this is all that's happening. The resolution happens. And let's take this dictionary and put it in another list, let's say L1, and you can have this dictionary D here. And then this refers to this, and this refers to this, and then it goes on all the way until you can find a value, right?
Okay, does it happen only for integers, or is like it happens for strings or floats as well?
Does it happen for strings or floats? Let's find out. So that is the notes part. I will make a better representation and then share it with you. For now, let's switch screens and then go back.
Pawan, actually, we declare as L, L equal to -5, comma A, comma P. Yeah. Suppose if I will tell it at A, how it is memory reference in L data structure.
Okay, let's recreate that. It should also be 1 second. Let me pull up that notes here also so that you can refer back and forth. It might take a minute.
Bhavani, I have a initial basic question. So you mean to say like the number between -5 and 256 is already there in the memory? Okay. So even if I define a number like L equal to some 256, 10 or 10 and 25, so it will refer to the existing memory location. Is that what you mean?
Yes. So there are two concepts that
Okay,
we
even if it is it is a variable or just a number, it will always refer to that memory location.
Yes, -5 to, we refer two concepts. One is the memory optimization, right?
Okay.
The memory optimization part is only for -5 to 256. After that, you
Yeah.
put any number, it's a different memory space altogether. The second thing is memory allocation. Memory allocation happens for independent variables, and every time you refer that variable, you're going to refer to that memory address, not to the value. You don't create another A, another B. You refer to that value. Memory allocation is referring the memory address present. Now let's see these two in action. Let's create two variables, right? A, which is 10,000, B, which is 10,000, C, which is -5. But this -5, let's also create D, which is also -5. And I refer -5 here, D here, C I haven't used. Cool. C. Now, what is ID of C? What will be ID of C? ID of -5 and ID of D. I should have done this so that you could see. So you can see all of these are same, right? So similarly, when I do ID of L of 0, it's going to be that same number.
Yeah, got it. Yeah.
No, I think L is not initialized again.
Oh, yes, great. Yeah, the same number. Cool, thanks for that. Similarly, if I do L of ID of L of 1, which is also D, it's going to be the same number. But the moment I do it for different number, let's say ID of 10,000, comma ID of A, comma ID of, already those are higher numbers, so it's going to have a different value. But let's also understand the second concept, which is the memory address allocation, ID of 0, 1, 2, right? Now you can see this is a completely different memory address, 216 something. Because it's a higher number, this memory optimization doesn't happen. It creates a separate memory address and stores it there. ID of A creates a separate memory address, stores it there. But list of 2, this place, you store the same memory address because it's this variable. The variable is A. So there are two different things happening here. Memory optimization, where you refer to the same memory address again and again. Here, every time you refer to a variable, you're always referring to the memory address of the variable, not the value. Cool. Until here, we want to see if you can run and play around with this, get the IDs. So if you have trouble with...
Bhavani, I have a question. Is there any reason for choosing -5 to 256?
Because it's frequently used numbers, even in the language design itself, they've come across this number so many times that they want to optimize that part.
Good question. Can you scroll down to the below example? Latest one, yeah.
Yeah.
So here you're saying like if you take that value separately and checking the the memory address, then it is differing for 10,000. But if you assign the 10,000 to a variable, and if you check that variable's memory address, it is same. I mean, the value is same, right? I mean, 10,000 is same 10,000, right? But the only difference is that you're not directly checking. You are checking after assigning it to a variable. So how it is differing here? That is the question.
Like I said, the memory optimization that Python does is only for numbers between -5 to 256.
Okay.
Any number more than that, that memory optimization does not happen. It creates a new address, stores it there. Which is why just 10,000, ID of 10,000 just like that, and ID of A, even though it's 10,000, is different. If you do ID of B, let's say, let's also do this, ID of B, comma, ID of L of 3. That should be fine. Now you can see, even though A and B are 10,000, it's two different addresses. But the L of 3 item is still B, so those two share the same address. And L itself has a memory address, which is very different from all of this. It's in its own place.
Okay.
And if you create a dictionary which has 1 : the list, then D of 1 will give you that item. This is a dictionary. And the ID of D of 1 will be this memory address, which we just saw, which is same as the one of the list. Now, if you take another dictionary, so another list L2, and make a dictionary a part of that, along with your A and B, then your ID of dictionary D will be equal to ID of L2 of 0. Oh, I haven't done L2 properly. Okay. L2 of 0. Even you can print this and see. So that's how the memory kind of keeps referencing itself. Yes, Abhishek.
Yeah, so okay, like Python is using whatever like frequently used numbers are, and like it is storing it in the same place, and we are referencing that place only, right? So if we change that, like if I have assigned A, let's say 5, and B also 5, something else like 6. Okay, but if I change B, it won't affect A, right? But it is referencing to the same memory location. So how does that make any sense?
Okay, brilliant question. I'm so glad you asked that. So, wonderful question. I'm glad that I have to go back to the notes so that actually, if I keep writing here, it should show up, hopefully. Somewhere here, I will write. 。  . 。 don't know how long it will take to sync up. Let's see. I'll just share the screen. Stop sharing this. Now, the question that he asked again, struggling with technical difficulties. Cool. The question he asked is this. Now I have all of this -5, -4, -3, all the way to 256 already in memory. And I have a bunch of variables. I have X, I have Y, I have Z. Now I have made all X, Y, Z all -5, and it has memory location 101, 102, 103, all the way to 107, let's say. It should be 257 or something like that. Cool. Now it only stores the memory address 100, 1 and 1001, 1001. What does that mean? X equal to -5, Y equal to -5, Z equal to -5. When I go back and say Y equal to 100, I don't go and change 1001. Rather, what I do is I will erase this memory reference, find out the address of 10. Let's say address of 10 is 1010. I will erase this and replace this with 1010. That's what happens when you reassign something. So you're not going and touching the value. So let's say that is for the memory optimized numbers. The numbers are going to be in memory no matter what. It's not going to get rewritten. It's only the address that's getting rewritten. Now let's say the same thing with 257. Let's say 257 is in memory address 1257. And I have another two set of numbers. A 257, A equal to 257, B equal to 257. Now I said I already have 257 in memory, but you won't go and refer this 257 because memory optimization doesn't apply. So I have to create a new memory place, right? 257, 1258, let's say, and then I will refer that memory address here. And again for B, I have to create a new memory space, 257, and then I'm going to create a new address, 1259. 1259 is here. Now I reassign A to, let's say, 10 again. Now what it will do, I know this is not memory optimized. I know this has to be erased off. Again, the erasing of part I will discuss more in garbage collection. You delete this memory reference and put it back to where 10 was. Let's say 10 was in 1010. So it's a matter of erasing that reference and then reassigning that reference. It's all happening at the memory address level, not at the value level.
Okay, so like that reference is getting changed, right? Like whenever we are assigning some other value, that reference is getting changed. So
Yes.
we are not replacing that reference, like that memory address.
No, we are not replacing that memory address for this one. In case of this one 257, which is just left like that, that will be cleaned up by garbage collection.
That will be done by GC,
Yeah.
but this was something which I want to know. Okay. Cool, it's clear. Thank you.
So now let's go back to our screen. I think probably that's the last time we use iPad. We don't need that anymore. Like I said, garbage collection kind of cleans up things. Okay, I think we need that one more time. How does it do? How does it know whether a particular memory space should be deleted or not? We are not deleting it manually. We are just replacing things and hoping that everything works. How it does is by a concept called reference counting and garbage collection. Reference counting is every time you refer to a variable internally, it kind of keeps a count. So to this example here doesn't do justice. So let me do a different example. let's say I have the same variable 256. Here it doesn't matter. Let's actually get rid of 256 altogether. Now, sys is a Python package, internal built-in package. You can import it by using import sys. And if you do sys dot get reference count of A, you can see 2. But I have mentioned it only once. Don't get confused by that, because when you send it to a function, sorry, get reference count, a function, it creates a copy of it. So it also refers, the function also refers to it. So you're getting 2. Now, if I do b equal to a, and then I make another call, that's not right, because yeah, I have to keep running it. So every time you refer to that variable, the count kind of keeps incrementing. Now I assign C equal to A, D equal to A, keep doing this. Now I have 1 reference here, 2 reference here, 3, 4, and 5. So this should change to 5. Now, the thing is, I can delete D. I can delete C. Now, the moment I delete these two, the reference count decreases, right? Because two things have stopped. Every time something refers to something, the reference count increases. Every time something gets stopped getting reference, the reference count decreases. This happens for all data structures. Even if you deal with a string, it happens for the string also. So let's actually go and do this. Reference count remains 2. I rerun this. Reference count remains 5. I delete 2, I get 3. I can keep on deleting things. Delete B, and then the system reference count becomes 2. At a point, let's say you cannot see it, because if I delete A, I cannot pass A to this function. So it's not possible. But at some point, A will also get deleted, because let's say the file itself goes down. What garbage collection does is, it goes through all this reference count, which is maintained internally in Python. And anything that has 0 reference count, nothing is referring to it, it deletes it. And that's how garbage collection works. This reference counting mechanism is a very intelligent way of seeing what is in use and what's not in use. Even though it's an intelligent way, it's the best design decision that they can come up with. Python is a very old language. And this came when we had single core systems, or very small amount of number of cores was very less. This reference counting is also what's stopping us from having a more optimized version of Python. Because when 2 threads are writing to the same object, it's trying to increase and decrease this reference count. The GIL, Global Interpreter Lock, GIL, called Global Interpreter Lock, kind of comes into the picture and says, hey, something else is writing this, you cannot touch it until this reference count part is completely done. So what GIL does is, it holds that memory space, or it holds that process until the whole thing is completely updated. The reference count has to be updated, the value has to be updated, all the memory calculations has to be done. Until then, this global interpreter lock will be alive. After which you can do this, which is why multi-threading in Python is slow. Because even if you have multiple threads, all the threads has to wait until all the reference counts are updated and the memory references are resolved. But whereas multi-processing is a little bit faster, because every process has its own global interpreter lock, and it can keep increasing the memory addresses in its own space. But it cannot share those variables with each other process. Each process will have its own memory space, which is why multi-threading in Python is only recommended for IO-based tasks. IO-based tasks, when you're writing a file, making an API call, whereas multi-processing, you can do it for all CPU functions. When you're calculating something, reading a large file, reading values that are very large. So that is why global interpreter lock is, again, a very essential need. But given the current state of things, in multi-threading, you cannot really scale it across all the cores. Whereas with multiprocessing, you can. So Python is still faster. That's the argument. If someone says Python is slow, this is what you should say. What is the difference between multi-threading and multiprocessing? Great question. We are going into CS fundamentals. I'll still say. So as you all know, every program in computer is a process, right? It's one process or multiple process running all together. The Zoom that you're running, it has one process for, let's say, the UI, one process for sending the data, all that. So in computer, you have a process, and each process can have multiple thread. Thread 1, thread 2, thread 3. And all these threads will have the same memory space, same space where it writes and reads data from. When I say memory space, it's the RAM, right? Whereas in case of process, you have P1, P2, and P3. This is the simplest explanation. There is much more nuance to this. P1 will have its own space in RAM. Like if you open your activity monitor, you can see it has its own set of resources. So P1 will have its own set of resources, P2 will have its own set of resources, P3. And these three can operate independent of each other. Whereas in this case, if you kill this process, all these threads are going to die, right? Threads can also do independent tasks. Now this thread can go and read something from the internet. This can calculate 1 to 100 and multiply that. This can do some calculation. This can also do things independently. These can also do things independently. The only difference is these all share the same memory address. Something happens to this memory space when the process is running, it will affect all three threads. What do I mean by that? Let's say you have a variable X, and this is a very important variable holding very confidential data. And this is now 1000. This is the most confidential data. I'm using sarcasm here. Confidential data. And then T1 suddenly decides, I am going to change this confidential data. You deal with it. So T1 goes and does X equal to 25,000. Now T2 and T3 has to deal with it. It has no say in, what changes what. And then there are times when both T2 and T3 wants to read this X, and it will be in a deadlock. It will be in lock, right? Who is going to go first? So these are the things that's happening inside a thread when both are happening at the same time. Whereas in multiprocessing, everybody has its own space. Everybody will write in their own space. And finally, they'll come and say, hey, I have this number. Do you also have this number? Let's take a simple sorting problem, right? Let's say you want to sort 10,000 numbers and you split it across three different processes. You split 10,000 by 3 and then just give 333 plus to each, right? You're giving 333 to each numbers. Each of them will do sorting in their own space and come up with the outcome. I'm just randomly going to give numbers because this kind of math I'm not very comfortable with. And finally, as output, you have 333, 666, and 999. Now, there should be another process which will take the three numbers and then find out what is the biggest number in this three, which is 999. Well, obviously, and that's not even close to 10,000. What was I thinking? But yeah, that's how it does the operation in its own space and gives you the result for you to intervene. That's the difference between multiprocessing and multi-threading. Bringing it back to Python, in Python, it doesn't do multi-threading well in numerical operations or something that has to involve CPU. Whereas it does it very well in IO because it's going to just hand off the request and get back the request. Okay, so, and why is that? Because it has global interpreter lock. When you have global interpreter lock, two threads trying to access a variable will kind of always be in a clash with each other. Thereby, you don't get the you don't get the performance that you're looking for with threading. The whole point of threading is splitting in the task into multiple threads. So that performance benefit you're not going to get. So that's a lot of theory. I'm going to stop and then take a good breath. You all can ask questions. And by this time, you should also be able to run these things in your local system. If not, let me know. And we have a lot of ground to cover. Did I not share my screen the whole time?
No,
You
ma'am.
did.
Okay. When we say good, doesn't mean that it's a different GC implementation. No, it doesn't have a different GC implementation. It has the same implementation, just that it will, when you say implementation, yeah, it will have a different garbage collector, yes, for each memory space that, for multiprocessing. Okay, this one should be, okay, cool. Now, just yes, Abhishek.
Yeah, I'm able to open this Jupyter notebook, but I think I'm not able to get these files, and yeah.
Okay, you should be in the same directory as the project. If you open it in a different directory, so I am in the depths of Python directory, which is the same directory as the GitHub repository. Inside this, if you do Jupyter notebook, it should open this.
Okay, but I did create that VNV, so is it real because of that?
No, VNV is not a problem.
Okay. Let me open it again.
Can others confirm? Please put in the chat if you can open, run, and
Like same cell, I'm able to run. There is a run button above.
okay, let's actually tackle that. I'm going to give you small commands. So command I'm using a Mac, so it's command. If you're on Windows, it's control. So command plus enter will run the shell. Command plus enter will run the shell. If you also hover over this, it will give you the shortcut on the right. Right? Run the cell in advance, command plus enter or control plus enter. Now, if you want to introduce new cells, which we do very often, if you want to introduce new cells, escape. This is a little bit difficult, or you can also do, I think plus here, yeah, plus here to introduce more cells. And what I do is escape and then A to add before, and escape and B to add after. Escape A to add before a particular cell, escape A to add after a particular cell, and escape DD to delete. Escape DD to delete things. Okay. So I will also leave this somewhere. Escape A to add, escape B to add after. This is add before. And then escape DD to delete. Control or command plus enter to run. Okay. This is going to error out, so it's marked down. Good. Abhishek, can you share your screen so that we can see what's happening?
Yeah, wait.
Everybody else, can you give me a thumbs up? It's running, your shells are running.